Good morning, my dear students. Welcome back to the discussion of remaining part of the topic classification of elements and periodicities in properties. After having gone through all the details in our last visit, we have discussed very important aspect atomic radius. As we have come to know, there is no any practical method to have a precise value for atomic radius, but someone using X-ray technique or some other spectroscopic technique, to some extent we can find out, we can measure the atomic radius. Depending upon the situation, the atomic radius is being discussed in terms of covalent radius and metallic radius. Apart from these, we have also discussed van der Waals radius and even ionic radius. We have come to know in all the vertical columns, in the groups, in the families, with increase in atomic number, the atomic radius goes on increases because the added electron goes to the new principal quantum number. Consequently, atomic radius increases, the force of attraction decreases. On the other hand, along the period, in any horizontal row, the added electron, every incoming electron goes to the same principal quantum number level, which leads to the increase in the effective nuclear charge. Consequently, the atom will shrink. Both atomic radius and ionic radius goes on decreases. In this connection, we have discussed graphical representation for first group alkali metals and along the period for lithium and beryllium onwards, and for halogen family also. As for NCERT information, we have discussed the graphical information. Soon after that, we are talking about ionization energy, that we have defined as the amount of energy required to remove the electron from an isolated gaseous neutral atom, that we have represented by means of, say for example, M gas. We have removed one electron from this atom. This has become now cation. This energy is called as ionization energy or ionization potential athava ionization enthalpy. Always this process is endothermic in nature. It is always endothermic process, means it will have a positive quantity. Always endothermic means the value will be in terms of positive quantity. It is written as enthalpy of ionization. Enthalpy of ionization. And suppose you remove one more electron from the M plus, that becomes, now we have M plus gas becomes M2 plus gas. It has lost one more electron. We call it as second ionization energy. Means to remove one electron from the isolated neutral gaseous atom, it is called as first ionization energy. To remove one more electron, whatever the energy we supply is known as second ionization energy. Likewise, if you remove one more, it becomes third. Therefore, in general, the CET point we have discussed is, now generally ionization energy IE3 is greater than second ionization energy, which is greater than first ionization energy, because we have said M3 plus ion size is less compared to M2 plus, and M2 plus size is less compared to M plus, and M plus size is less compared to M. So likewise, as the positive charge increases, size goes on decreases, ionization energy goes on increases. So this information today we shall extend its variation in the group 3 table. First we write variation of ionization energy, variation of ionization energy down the group. Sometimes question for 2 mark. How does ionization energy vary down the group and along the period? Answer: down the group, ionization energy goes on decreases because there is increase in the atomic size. Means ionization energy is inversely proportional to atomic size. So we say a point down the group it decreases, down the group it decreases with increase in atomic size, If you see in any vertical column, in any family, any group, we see there is increase in the size of atom, the force of attraction is becoming less and less, therefore the amount of energy required to remove that electron goes on decreases. This point to be noted. Now we take graphical representation for this. Take this graph. Now you write along the y-axis we take ionization energy. It is written as enthalpy of ionization energy. Multiple choice question. Its unit of ionization energy is kilojoule per mole. Question for CET, multiple choice question. What is the unit of ionization energy? Its unit is kilojoule per mole. The amount of energy required to remove 1 mole of electron, not one single electron. Getting a single atom itself is very, very difficult. How can we get a single electron? It is a very, very unbelievable thing. So hence 1e means it is 1 mole of electron. 2e means 2 moles of electron. You have learnt in some basic concept, 1 mole concept. 1e means 1 into 6.02 to 10 power 23 electrons are said to be 1 mole of electrons. Always we speak in terms of bulk quantities, not a single electron or single proton, because they are very, very minute, very, very microscopic aspect. It is very difficult to isolate. Hence we take this term. Hence unit is kilojoule per mole. We see down the group lithium, sodium, potassium, rubidium and cesium. Variation will be there. Lithium, sodium, potassium, then this is cesium. All these things, elements, you can see the location. We can write lithium, sodium, potassium, rubidium and cesium. This we write it as cesium. So this is the variation of ionization energy down the group: lithium, sodium, potassium, rubidium and cesium. The francium is radioactive element. We leave from this discussion. So remember, there is a decrease in the magnitude of ionization energy down the group. This is the information. And one more thing to be noted, with decrease in ionization energy, the reactivity goes on increases. Point to be noted for CET purpose. Point to be noted for CET need purpose. With decrease in ionization energy, with decrease in ionization energy, reactivity goes on increases. Reactivity goes on increases. Point to be noted, my dear students. Without failing, copy this. ಇನ್ನೊಂದ್ಸರಿ ಕೇಳಿ, ಡೌನ್ ದ ಗ್ರೂಪ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದ, ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದ, ಆ ಕೊನೆ ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿಲಕ್ಕ ಬಹಳ ಈಸಿ ಆಗ್ತದ. and the ionization energy goes on decreases. Ionization energy goes on decreases means reactivity increases. So mathematically, ionization energy is, it is small means more reactivity, it is inversely proportional to reactivity. Ionization energy is inversely proportional to reactivity. Lesser the ionization energy, larger is the atomic size, more is the metallic character, more is the tendency to lose electron, so more is the reactivity. So point to be noted, the first group alkali metals have got the least ionization energy because atomic size is very large in the periodic table. Once again, if anybody happen to ask you which family, that is alkali family. First group elements are the one which have got the largest atomic size, therefore least ionization energy, they are most reactive. For that purpose only they are kept under kerosene or some other organic solvent. So don't get confused. In the today's information, the first heading was definition of ionization energy, its unit, how does it vary, or down the group we have taken the points and graphical represent is also given on the board. Now variation along the period. Variation along the period. We take here, point to be noted. Now in down the group we take it as along the period. We write variation of ionization energy along the period. Along the period. Period means from left to right in the horizontal manner. Now its unit is kilojoule per mole. Well, see this graph now. Before that, you remember generally along the period with increase in effective nuclear charge, the electrons are very close to the nucleus. To pull it, we should put more amount of effort, more energy. Therefore, the point is, I write here, along the period, ionization energy increases. For better knowledge, due to increase in effective nuclear charge or due to decrease in atomic size, due to decrease in atomic size, So remember, ionization energy is directly proportional to effective nuclear charge and inversely proportional to atomic size and ionic size. I repeat, ionization energy is directly proportional to effective nuclear charge. Directly proportional to effective nuclear charge. Ionization energy is directly proportional to effective nuclear charge, and ionization energy is inversely proportional to atomic size or atomic radius or ionic radius or ionic size. And ionization energy is less energy, more reactivity. That is inversely proportional to reactivity. Atomic or ionic size. Atomic or ionic size. I read just to see it may not be visible properly. I write here. Ionizing energy is directly proportional to effective nuclear charge. First point. Second information, ionization energy is inversely proportional to atomic size or ionic size. Atomic size or ionic size. Third point, ionization energy is inversely proportional to reactivity. This is the information useful for CET purpose. So, more effective nuclear charge, more proton, more pull, less is the charge. That is, less will be the size. So, ionization energy more. If ionization energy is more, atomic size or ionic size less, inversely proportional, and lower the ionization energy, more is the reactivity. So, note this information. We give the graphical information now. This you write atomic number. Please, in previous graph also, without fail you take atomic number Z on the x-axis. Now we take it as lithium, beryllium, boron, carbon, nitrogen, oxygen. See this graph. This is lithium, beryllium, boron. This is carbon. This is nitrogen, oxygen, and fluorine. Further, neon. Look at the board carefully. Enthalpy of ionization on the y-axis and atomic number on the x-axis. We are studying now variation of ionization energy along the period. I am taking second period, lithium to neon. This is, you see the values, lithium is lower, beryllium is more, and again boron coming down means energy decreases. Again carbon increase, nitrogen increase, whereas oxygen decreases, and again fluorine, neon goes on increases. Best theory as well as NEET question on these issues. Once again, we are discussing the graphical representation for the variation of ionization energy along the period. Andre in the horizontal rows olaga ನಾವು ತಗೊಂಡದ್ದು ಸೆಕೆಂಡ್ ಪೀರಿಯಡ್ ಅದ ಲಿಥಿಯಂ ಹಿಡ್ಕೊಂಡು ನಿಯಾನ್ ತಗೊಂಡಿದ್ದೀವಿ. ಇಲ್ಲಿ ಬರ್ದೀನಿ, ಇದು ಹೈಟ್ ಕೆಳಗೆ ಅಂದ್ರೆ ಎನರ್ಜಿ ಕಮ್ಮಿ ಇರ್ತದ. ಬೆರಿಲಿಯಂ ಎನರ್ಜಿ ತೆಗಿಬೇಕಾದ್ರೆ ಜಾಸ್ತಿ ಬೇಕು, ಮತ್ತು ಬೋರಾನಿ ಕಡಿಮೆ ಬೇಕು, ಮತ್ತು ಕಾರ್ಬನ್ ಮತ್ತೆ ಹೆಚ್ಚಿಬೇಕು, ನೈಟ್ರೋಜನ್ ಜಾಸ್ತಿ ಬೇಕು, ಮತ್ತು ಆಕ್ಸಿಜನ್ ಕೆಳಗೆ ಇರ್ತದ, ಎನರ್ಜಿ ಕಡಿಮೆ ಬೇಕು, ಮತ್ತು ಫ್ಲೋರಿನ್ ಮ್ಯಾಗ ಹೋಗ್ತದ, ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬೇಕು. ಈ ಟೈಪ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಅದ. ಈಗ ಇದು ಫ್ಲೋರಿನ್, ದಿಸ್ ಇಸ್ ಆಕ್ಸಿಜನ್, ನೆಕ್ಸ್ಟ್ ಫ್ಲೋರಿನ್ ಅನ್ನು, ದಿಸ್ ಇಸ್ ಆಕ್ಸಿಜನ್. Now you see question expected. The thing is, why the ionization energy of beryllium is more compared to boron? Give reason ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ. And in case of multiple choice question, the ionization energy of beryllium is more than that of boron. Which reason is correct among the all four answers? ನಾಲ್ಕು ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಒಂದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ನಾವು ಬಳಸ್ಕೋಬೇಕು. Now I discuss that particular point. Look at the board. Now beryllium atomic number 4. Beryllium atomic number 4, we write it as 1s2, 2s2. Boron atomic number is 5. We write it as 1s2, 2s2, 2p1. See the chemist here. The reason we have to give why the ionization energy of beryllium is more than boron. Give reason. Answer: since in beryllium the 2s electrons are more penetrated towards the nucleus, andra ಆ 2s fully filled ಅದ, more stable ಅದ, nucleus in ಕಡೆ ಬಹಳ ಜೊಗ್ಗಲ್ಪಟ್ಟವ, they have got more penetration towards the nucleus. ಹೀಗಾಗಿ ಆ ಜೋಡಿಗೆ ತೆಗಿಬೇಕಾದ್ರೆ we have to give more energy, whereas that electron in 2p1 ಏನಾಗದ ನ್ಯೂಕ್ಲಿಯಸ್ ಕಡೆ ಬಹಳ ಜೊಗ್ಗದಾಗಿಲ್ಲ, ಅದು ಸ್ವಲ್ಪ ಫೋರ್ಸ್ ಕಮ್ಜೋರ್ ಅದ, ಅದಕ್ಕೆ ಆರಾಮ್ಸೆ ಓಡಿಸ್ಬೋದು ಹೊರಗೆ. ಕೇರಮ್ ಬೋರ್ಡ್ ಸ್ಟ್ರೈಕರ್ ಕಾಯಿನ್ ತೊಗೊಂಡು ಹೊಡೆದಂಗಾಗಿ ಹಿಂಗ ಕಾಯಿನಿಗೆ ಸ್ಟ್ರೈಕರ್ ತೊಗೊಂಡು ನಾವು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮಾಡ್ದಂಗಾಗಿ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸಿಲಿ ಔಟ್ ಆಗ್ತದ. ಇನ್ನೊಂದು ಸರಿ, ಇಫ್ ಯು ಸಿ ದಿ electronic configuration, one thing you decide always, the halfly filled configuration and fully filled configuration are more symmetric configuration, they have got more stability. ಅಂಥವಕ್ಕೆ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಬೇಕಾದ್ರೆ we have to supply more amount of energy. So the answer I give in a limited words, since in case of beryllium it is fully filled, more stable configuration. In other words, the 2s electrons are more penetrated towards the nucleus, ಅಥವಾ it has got more effective nuclear charge. ಹೀಗಾಗಿ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನು ತೆಗಿಬೇಕಾದ್ರೆ ನಾವು ಸಾಕಷ್ಟು ಎನರ್ಜಿಯನ್ನು ಕೊಡಬೇಕು. ಆದರೆ ಈ ಬೋರಾನ್ದಲ್ಲಿ ಆ 2p ಎಲೆಕ್ಟ್ರಾನ್ ಏನದಲ್ಲ ನ್ಯೂಕ್ಲಿಯಸ್ ಕಡೆ ಬಹಳ ಜೊಗ್ಗಲ್ಪಟ್ಟಿಲ್ಲ, ಫೋರ್ಸ್ ವೀಕ್ ಅದ, ಮೇಲಾಗಿ ಅದರಂಗೆ ಫುಲ್ಲಿ ಫಿಲ್ಡ್ ಇಲ್ಲ. ಹೀಗಾಗಿ ಇಲ್ಲಿ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಕಮ್ಮಿ ಅದ. 2p1 electron is less penetrated towards the nucleus. Due to this, force of attraction is weaker. Therefore, you can easily remove electron from the boron compared to the beryllium. This is one information. Similarly, mat nitrogen option ide type ide style. Nitrogen atomic number 7. We write 1s2, 2s2, 2p3 ಅಂದ್ರೆ x1 y1 z1 ಅನ್ನಂಗ. ಓದಿದ ಅಟಾಮಿಕ್ ನಂಬರ್ 8. we write as 1s2, 2s2, ಆಮೇಲೆ 2p4. ಇಲ್ಲಿ ನೋಡಿ ಬೋರ್ಡ್ ನೋಡಿ ಸರಿ, ಗ್ರಾಫ್ ನೋಡ್ರಿ. ನೈಟ್ರೋಜನ್ ಹೈಟ್ ಜಾಸ್ತಿ ಅದ ಅಂದ್ರೆ ಎನರ್ಜಿ ಅನ್ನೋದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಅದ, ಓ ಏನಾದ್ರೆ ಕೆಳಗಡೆ ಎನರ್ಜಿ ಕಡಿಮೆ ಇರ್ತದೆ. ಇದಕ್ಕೆ ಮುಖ್ಯವಾದ ಕಾರಣ ಏನು ಅಂತಂದ್ರ, ಇನ್ ಕೇಸ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಇಟ್ ಹ್ಯಾಸ್ ವಾಟ್ halfly filled configuration under 2p3. It is more symmetric, more stable, more effective nuclear charge. But in case of oxygen it is 2p4, which is less penetrated. ಇದಕ್ಕಿಂತಲೂ ಇದು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ರೌಡ್ ಜಾಸ್ತಿ ಅದ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಮೋರ್, ರಿಪಲ್ಷನ್ ಈಸ್ ಮೋರ್. ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಅಟಮ್ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಹಿಗ್ದಂಗೆ ಆಗ್ಬಿಡುತ್ತೆ. ಒಂದು ಜರ ಸೈಜ್ ಇರೋದು ಓದು ಸೈಜ್ ಹೆಚ್ಚಾಗೋದ್ರಿಂದ ಆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಏನಾಗ್ಬಿಡುತ್ತೆ, ವೀಕ್ ಆಗೋದ್ರಿಂದ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ತೆಗಿಲಕ್ಕ ಬಹಳಷ್ಟು ಅನುಕೂಲ ಆಗಿರ್ತದೆ. ಇನ್ನೊಂದು ಸರಿ, ಇನ್ ಕೇಸ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ದ ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ ಇಸ್ ಮೋರ್ ಕಂಪೇರ್ಡ್ ಟು ಆಕ್ಸಿಜನ್. ಆನ್ಸರ್: ಸಿನ್ಸ್ ಇನ್ ಕೇಸ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಇಟ್ ಇಸ್ ಹಾಫ್ಲಿ ಫಿಲ್ಡ್, ಇಟ್ ಇಸ್ more stable, more symmetric, effective nuclear charge is more, force of attraction is more. So to remove the outer electron we have to supply more amount of energy. However, in case of oxygen it is 2p4. ಖರೆ ಅದು ಇದನ್ನು 2p ಅದ, 2p ಇಲ್ಲಿ 3 ಅದ, ಇಲ್ಲಿ 4 ಅದ. So more electrons are there, repulsion is more between the electrons. As a result the atom will expand more. ಇದರ ಪರಿಣಾಮವಾಗಿ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಏನಾಗ್ಬಿಡ್ತದ, ಡಿಕ್ರೀಸ್ ಆಗ್ತದ. ಸೊ ಅವಾಗ ಎನರ್ಜಿ ಏನಾಗ್ತದ, ಕಡಿಮೆ ಬೇಕು ನೋಡ್ರಿ. ಇದೇ ಟೈಪ್ ನಾವು ಹೋದೆವು ಮುಂದೆ CET ಬೆಳ್ಕೋತ ಹೋದಾಗ. ನಿಯಾನ್ ವಿಲ್ ಹ್ಯಾವ್ ದಿ ಹೈಯೆಸ್ಟ್ ಇನ್ ದ ಈಚ್ ಪೀರಿಯಡ್. ನೀವು ಫಸ್ಟ್ ಪೀರಿಯಡ್ ಹೋಗ್ರಿ, ಸೆಕೆಂಡ್, ಥರ್ಡ್, ಯಾವುದೇ ಹಾರಿಜಾಂಟಲ್ ರೋದಾಗ ಹೋದಾಗ every end period will have a noble gases. So alkali metals will have the least ionization energy, and noble gases will have the highest ionization energy because they are fully filled octet configuration ಅದ ಸ್ಟೇಬಲ್ ಆಗಿರ್ತವ. ಸೊ ಯಾರಾದ್ರೂ ನಮಗೆ ಕೇಳಿದ್ರೆ ಅಂತಂದ್ರೆ in any particular period alkali metal will have the lowest, the least amount of ionization energy. On the other hand, noble gases will have the highest magnitude of ionization energy. These are the point to be noted in the particular table, in this particular information. Now, no need to by heart any values given in the NCERT book. Just for the sake of understanding, the values have been given. ಯಾವ ಕೊಟ್ಟಂಥ ವ್ಯಾಲ್ಯೂಗಳು ಇವು ಅಲ್ಲಿ ಡಾಲ್ಟನ್ಸ್ ವ್ಯಾಲ್ಯೂಗಳಲ್ಲಿ ಡೋಬರ್ನಿಯರ್ ಯಾವೇ ಕೆಲವು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿರ್ತಾರ ಎಲ್ಲನೂ ಬೈ ಹಾರ್ಟ್ ಮಾಡ್ಬೇಕಂತ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಬಟ್ ನಿಮ್ಗೆ ಅದಕ್ಕೆ ರೀಸನ್ ಗೊತ್ತಿರಬೇಕು. ಈ ಗ್ರಾಫ್ ನೋಡಿದ ತಕ್ಷಣ ಹೇಳಬೇಕು ವಿನಃ ನೀವು ವ್ಯಾಲ್ಯೂ ತೊಗೊಂಡು ರಟ್ ಹೊಡೆ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇಸ್ ವೆರಿ ವೆರಿ ಎಸೆನ್ಷಿಯಲ್ ಅಟ್ ದಿಸ್ ಮೂಮೆಂಟ್. ನೆನಪಿರಲಿ, ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಕ್ವಶನ್ ಬೆರಿಲಿಯಮ್ ಬೋರಾನ್ ಕಂಪೇರ್ ಮಾಡ್ತಾರೆ, ನೈಟ್ರೋಜನ್ ಆಕ್ಸಿಜನ್. ಸೊ ಫೈನಲ್ ಕನ್ಕ್ಲೂಷನ್ ಈಸ್ always ionization energy is going to decide the reactivity of an atom or ion, and it depends upon the size of atom or ion. Generally in any vertical column, due to increase in atomic size it goes on decreases along the period. Due to decrease in atomic size and ionic size it goes on increases. So these are the point we have discussed just now with the graph. All those informations have been supplied to you. Go through NCERT, read modern ABC for understanding purpose. Next time we take up shielding or screening effect. Shielding or screening effect. Shielding or screening effect. This is question for 1 mark. Question for 1 mark. Imagine this is nucleus, orbit. Okay. This is nucleus. Here protons are present in the nucleus. Now we are trying to understand the meaning of screening effect or shielding effect. Screen, to shield, ಪರದೆ ಹಾಕೋದು, ಮರಿ ಮಾಡೋದು ಅಂತ ಅರ್ಥ. Just imagine here, this is an atom. In the center nucleus is present. Inside the nucleus we have protons and neutrons. Imagine there are electrons here. This nucleus is trying to pull this outer electron, but this inner electrons will try to prevent it. Means this electron is going to repel this electron. As a result, this electron goes away from the nucleus. Imagine it is something like your father is trying to beat you and your mother comes in between. Imagine your mother is inner shell electron, you are outer shell electron. The papa is trying to beat you, the mummy is coming in between, a whole bit ಅಂತ ತಿಳ್ಕೊಂಡು she is coming and screening you, shielding you. ನೀವು ಬಂದು ಮರಿ ಮಾಡ್ತಾರ, ಪರ್ದ ಹಾಕ್ದಂಗೆ ಆಗಿಬಿಡ್ತದ. ಆ ಮಮ್ಮಿ ಬರೋದ್ರಿಂದ she is also like electron, we are also like electron, we repel each other. ಇದರ ಪರಿಣಾಮವಾಗಿ ನಿಮಗೆ ಎಷ್ಟು ಏಟು ಬೀಳಬೇಕಾಗಿತ್ತು, ಎಷ್ಟು ಗಚ್ಚು ಕೊಡಬೇಕಾಗಿತ್ತು, ಆ ಪೆಟ್ಟು ನಿಮಗೆ ಹತ್ತೋದಿಲ್ಲ. ಅದೇ ಟೈಪ್ whatever the nuclear force it was supposed to experience, ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಹೊರಗಿನ ಎಲೆಕ್ಟ್ರಾನಿಗೆ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ನಿಂದ ಎಷ್ಟು ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಅನುಭವಿಸಬೇಕಾಗಿತ್ತು ಅದು ಅನುಭವಿಸೋದಾಗೋದಿಲ್ಲ. ಯಾಕಂದ್ರೆ ಇದು ಅಡ್ಡ ಬರೋದ್ರಿಂದ ಇದಕ್ಕೆ ರಿಪಲ್ಷನ್ ಆಗಿ ದೂರ ಸೇರ್ತದ, ಇದ್ರ ಪ್ರಭಾವ ಇದಕ್ಕೆ ಕಡಿಮೆ ಆಗ್ತದ. ದಟ್ ಫೆನಾಮಿನನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಆರ್ ಸ್ಕ್ರೀನಿಂಗ್ ಎಫೆಕ್ಟ್ ಅಂತ ಕರೀತಾರೆ. I repeat, here it is a phenomenon in which outer shell electron experience less nuclear force, less nuclear charge due to the repulsion between the inner shell electron. ಅಂದ್ರ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಏನು ಮಾಡ್ತದ, ಇದಕ್ಕೂ ಜೋಗ್ತಿರ್ತದ, ಇದಕ್ಕೂ ಬಾಂದ್ ತಿಳ್ಕೊಂಡು ಪುಲ್ ಮಾಡ್ತಿರ್ತದೆ. ಇದಕ್ಕೆ ಪುಲ್ ಮಾಡೋದ್ರಿಂದ ಇದು ಸಮೀಪ ಬರದಿಂದ ಇದಕ್ಕೆ ರಿಪಲ್ಷನ್ ಆಗಿ ಏನಾಗ್ತದ, ಹೋಲ್ ಬಿಲ್ಡರ್ ಹೊಡಿಬೇಡ ಅವನಿಗೆ ಹೇಳ್ತೀನಿ ತೋರೆ ತಿಳ್ಕೊಂಡು ಏನು ಸರಿ ಹಿಂದಕ್ಕೆ ತಿಳ್ಕೊಂಡು ಟ್ರೈಂಗ್ ಟು ಬ್ಲಾಕ್ ಸಮಥಿಂಗ್. ಸೊ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪುಲ್ ಮಾಡಬೇಕಾದ್ರೆ ಇದು ಅಡ್ಡ ಬಂದ್ಬಿಡ್ತದೆ. ಈಗ ಅಡ್ಡ ಸಮೀಪ ಆಗೋದ್ರಿಂದ ಇದಕ್ಕೆ ರಿಪಲ್ಷನ್ ಆಗಿ ಮತ್ತೆ ದೂರ ಸರಿಬಿಡ್ತದೆ. ನಾರ್ತ್ ಪೋಲ್ ರಿಪಲ್ಷನ್ ಆಗಿ ದೂರ ಸರಿಬಿಡ್ತದೆ. ಅದು ದೂರ ಸರಿಯೋದ್ರಿಂದ ಅದಕ್ಕೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಬೀಳ್ಬೇಕಾಗಿತ್ತು, ಎಷ್ಟು ಪ್ರವಾಹ ಅದಕ್ಕೆ ಅನುಭವಿಸ್ಬೇಕಾಗಿತ್ತು, ಅದು ಅನುಭವಿಸೋದಿಲ್ಲ, ಕಡಿಮೆ ಫೀಲ್ ಆಗ್ತಿರ್ತದೆ. ಐ ರಿಪೀಟ್, example you see lithium atomic number 3 we write 1s2 2s1. ಇದು 1s2 ಇದು 2s1 ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. I am trying to convince you the meaning of shielding effect or screening effect. ಮರಿ ಮಾಡೋದು, ಮುಚ್ಚೋದು, ಹೈಡ್ ಮಾಡೋದು ಅಂತ ಅರ್ಥ. ಸ್ಕ್ರೀನ್ ಅಂದ್ರೆ ಪರ್ದಾ ಬಂದಂಗೆ ನಡು ಬಂದ್ಬಿಡೋದು. You see, these two electrons are in the first orbit of lithium, and in the second orbit there is one more electron. And naturally what happens, atomic number 3 ಅಂದ್ರೆ there are 3 protons plus is the effective nuclear charge. ಇಷ್ಟು ಚಾರ್ಜ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಇರ್ತದೆ. 3 protons are trying to pull all the electron towards it. ಆ 3 ಪ್ರೋಟಾನ್ಸ್ಗಳು ಈ ಹೊರಗಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ತನ್ನ ಕಡೆ ಜೊಗಲಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡ್ತವೆ. ಅದು ಸಮೀಪ ಬಂದಂಗ ಆಗಾನೆ ಈ ಅಡ್ಡಕ್ಕೆ ಏನಾಗ್ತಾವ, ಇವೆರಡು ಕೂಡಿ ಇದಕ್ಕೆ ರಿಪಲ್ಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ. ಹೀಗಾಗಿ ಇದು ಏನು +3 ಚಾರ್ಜ್ ಅನುಭವಿಸ್ಬೇಕಾಗಿತ್ತಲ್ಲ, ಅದಕ್ಕಿಂತಲೂ ಚಾರ್ಜ್ ಕಮ್ ಅನುಭವಿಸ್ತದ. ಎಷ್ಟು ಚಾರ್ಜ್ ಅನುಭವಿಸ್ತದ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್. 3 ಕಲ್ಲವ, ನಾವು ಒಂದು ತಗೊಂಡು ಆ ಮ್ಯಾಂಗೋ ಮಾವಿನ ಗಿಡಕ್ಕೆ ಹೊಡಿತೀವಿ, 3 ಕಲ್ಲಾಗ 2 ಕಲ್ಲಿಗೆ ಫೇಲ್ ಆಗ್ತದ, ಒಂದೇ ಕಲ್ಲು ಬಿಡ್ತೀವಿ ನೋಡ್ರಿ. 1 ವಾಸ್ ಎಫೆಕ್ಟಿವ್ ಥ್ರೋ. ಆ 3 ಎಸೆತಗಳಲ್ಲಿ ಆ 3ನೇದು ಏನದ, ಒಂದೇ ಒಂದು ಎಸೆತ ಮಾತ್ರ ಸಕ್ಸಸ್ ಆಗಿತ್ತು, ಅದಕ್ಕೆ ನಮ್ಗೆ ಹಣ್ಣು ಸಿಕ್ತು ಅಂತ ಅಂದಂಗೆ. ಜಸ್ಟ್ ಲೈಕ್ ಶಾರ್ಟ್ ಪುಟ್ ಥ್ರೋ ತೊಗೊಂಡು ಥ್ರೋ ಮಾಡ್ತೀವಿ, ಒಂದು 3-4 ಚಾನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ದ ಬೆಸ್ಟ್ ವಿಲ್ ಬಿ ಸೆಲೆಕ್ಟೆಡ್. ಆ ಟೈಪ್. ಇನ್ನೊಂದ್ಸರಿ, ಸ್ಕ್ರೀನಿಂಗ್ ಎಫೆಕ್ಟ್ ಆರ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ಈಸ್ ಎ ಫೆನಾಮಿನನ್ ಇನ್ ವಿಚ್ the outer shell electrons will experience lesser nuclear charge due to the repulsion between the inner shell electron. ಈ ಹೊರಗಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಜೋಗಿಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡ್ತಾವ, ಅವು ಸಮೀಪ ಬಂದ ತಕ್ಷಣ the repulsion is taking place. So instead of +3 charge they experience less nuclear charge. So that is called as shielding effect or screening effect. Remember, this is shielding effect or screening effect is directly proportional to atomic size. Larger the atomic size, more is the atomic size, more is the ionic size, more is the ionic radius, more will be the screening effect, more will be the shielding effect. I write here shielding effect or screening effect. Screening effect or shielding effect is directly proportional to atomic size or ionic size. Atomic size or ionic size. Larger the atomic size ಅಥವಾ larger the ionic size, far away is the electron from the nucleus, lesser is the force experienced, lesser is the nuclear charge. Therefore, shielding effect ಅಥವಾ ಸ್ಕ್ರೀನಿಂಗ್ ಎಫೆಕ್ಟ್ is directly proportional to atomic size ಅಥವಾ ionic size ಅಥವಾ atomic radius ಅಥವಾ ionic radius. These are the definition of screening effect or shielding effect. And one more thing, how does it vary along the group, down the group and along the period? In any vertical column, na ಯಾವುದೇ ಟಾಪ್ ಟು ಬಾಟಮ್ ಬಂದಾಗ, with increase in atomic number, with increase in atomic size, the shielding effect goes on increases. Shielding effect goes on increases. and as shielding effect increases, ionization energy decreases. Andra shielding effect is inversely proportional to ionization energy. More is the shielding effect, more is the screening effect, more is the shielding effect, more is the screening effect, lesser is the nuclear force, lesser is the nuclear charge, and here it will be ionization energy will be less. More shielding effect, less ionization energy. It is inversely proportional, and down the group it goes on increases. Shielding effect increases, along the period it goes on decreases. It goes on decreases along the period. So down the group shielding effect increases, along the period shielding effect goes on decreases. True or false? Options ಕೊಟ್ಟಿರ್ತಾರೆ. You are supposed to remember these informations. Next we take up electron gain enthalpy. Next heading is electron gain enthalpy. So today we discussed definition of ionization energy, its unit kilojoule per mole, its variation in the group and along the period, its the factors affecting the ionization energy. Halfly filled, fully filled configuration are more stable, more is the stability, more will affect nuclear charge, more will be ionization energy, and we focused on beryllium and boron, nitrogen and oxygen by means of graphical representation. Then we have discussed about shielding effect or screening effect. We have said the phenomenon of it is a phenomenon in which the outer shell, the valence shell experience lesser nuclear charge due to the repulsion between the inner shell electron. Down the group it goes on increases, along the period it goes on decreases. Remember, the shielding effect is more means atomic size more. ಇವೆರಡು ಮೋರ್ ಆದಾಗ ionization energy ಕಡಿಮೆ ಇರ್ತದೆ. along the period shielding effect ಕಡಿಮೆ, ಸೈಜನ್ನು ಕಡಿಮೆ. ಇವೆರಡು ಕಡಿಮೆ ಆದಾಗ ಎಫೆಕ್ಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಏನಾಗಿರ್ತದೆ, ಹೆಚ್ಚಾಗಿರ್ತದೆ. ಸೊ ಇವ್ರ ಮ್ಯಾಗೆ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವಶನ್ಸ್ ರೇಸ್ ಮಾಡ್ತಾರೆ. ನಾವು ಆದಷ್ಟು ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡಬೇಕು. ಒಂದೇ ಸರಿ ಅರ್ಥ ಆಗೋದಿಲ್ಲ, ಒಂದು 3-4 ಸರಿ ನೀವು ರಿಪೀಟೆಡ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಸಕ್ಸಸ್ ವಿಲ್ ಬಿ ಯುವರ್ಸ್. ನೆಕ್ಸ್ಟ್ ಹೆಡಿಂಗ್ electron gain enthalpy. Question for 1 mark theory. Electron gain enthalpy. Electron gain enthalpy, or it is also called as, in simple words, electron affinity. Electron affinity, affection value and now electron gain enthalpy definition. Whenever an electron is added to the valence shell of an isolated gaseous neutral non-metal atom, only from the metal atom whatever the amount of energy we supply to remove the outermost shell electron, that energy is called as ionization energy, which always endothermic. ಅದೇ ನಾನ್ ಮೆಟಲಿಗೆ ಹೋದಾಗ ಕ್ಲೋರಿನ್ ಆಗಲಿ, ಸಲ್ಫರ್ ಆಗಲಿ, ಆಕ್ಸಿಜನ್ ಆಗಲಿ, ನೈಟ್ರೋಜನ್ಗಳು ನಾನ್ ಮೆಟಲ್ಸ್ಗಳವ. ಅವ್ರ ಕಾನ್ಫಿಗರೇಷನ್ ನೋಬೆಲ್ ಗ್ಯಾಸಿನ 8 ಆಲಕ್ಕೆ ಭಾಳ ಸಮೀಪವ. ಅವು ತಗೋತಾವ. ಆ ಎಲೆಕ್ಟ್ರಾನ್ ತಗೊಂಡ್ ಮಾಡಕ್ ಏನ್ ಎನರ್ಜಿ ಬಿಡುಗಡೆ ಆಗ್ತದೋ, ವಾಟ್ ಎವರ್ ದ ಎನರ್ಜಿ ಇಸ್ ಲಿಬರೇಟೆಡ್, that energy is called as electron gain enthalpy. Look at the board. Suppose we imagine X gas is a non-metal atom. We are adding 1 electron. Whatever the energy liberated, we call it as electron gain enthalpy. This becomes X minus gas. The energy is written as electron gain enthalpy. We write it as easy electron gain enthalpy. This first one is negative. I mean CET point electron gain enthalpy may be negative or positive. It may be negative or positive. But ionization energy is always endothermic. It is positive quantity. On the other hand, electron affinity ಅಥವಾ electron gain enthalpy may be endothermic or exothermic. ಪಾಸಿಟಿವ್ ಇರಬಹುದು, ನೆಗೆಟಿವ್ ಇರಬಹುದು. ಇಲ್ಲಿ ನೋಡ್ರಿ, here we are removed, we are adding one electron to this X, which is non-metal atom. As a result, it becomes X minus ion. Anion is formed here. Already there are some electrons in the valence shell of this X. ಯಾವ ಹೊರಗಡೆ ಮತ್ತೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಹಾಕೋಣ, ಆ ಹೊರಗಿನ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರ್ಗುಡಿಸೋದಿಲ್ಲ, ರಿಪಲ್ಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗಿಬಿಡ್ತದೆ. Somewhere in the bank, some people have gone to rob the bank to steal the money, ಅಮೌಂಟ್ ಕಾಲ್ ಮಾಡಕ್ಕೆ ಹೋಗಿರ್ತಾರೆ. ಮತ್ತೊಂದು ಗ್ಯಾಂಗ್ ಬರೋಣ, ಇಬ್ಬರ ಮಧ್ಯೆ ಘರ್ಷಣೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ನೋಡಿ. ಆ ಟೈಪ್ ಇಲ್ಲಿ ಒಳಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ಗಳಾವ, ನೀನು ಹೋಗಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಒಳಗೆ ಕಳ್ಸಟ್ಟಿಗೆ ಅವಕ್ಕೂ ಜಗಳ ಸ್ಟಾರ್ಟ್ ಆಗಿ ದ ರಿಪೆಲ್ ಈಚ್ ಅದರ್. ಸೊ ಡ್ಯೂ ಟು ರಿಪಲ್ಷನ್, ಆ ಮೋಡಗಳ ಘರ್ಷಣೆದಂಗಾಗಿ ಎನರ್ಜಿ ಇಸ್ ಲಿಬರೇಟೆಡ್ ಡ್ಯೂ ಟು ರಿಪಲ್ಷನ್ ಬಿಟ್ವೀನ್ ದಿ valence electron and incoming electron. Once again, it is defined as the amount of energy released when an electron is added to the isolated neutral gaseous non-metal atom. Example, X gas non-metal atom, we give one electron, this becomes X minus, means there is a repulsion between the outer shell electrons and incoming electrons. ಎರಡಕ್ಕ ರಿಪಲ್ಷನ್ ಆಗೋದ್ರಿಂದ ಎನರ್ಜಿ ಬಿಡುಗಡೆ ಆಗ್ತದೆ. that energy is called as electron gain enthalpy. ಇದು ಫಸ್ಟ್ ಕೇಸ್. ಈ ಸೆಕೆಂಡ್ ಏನು ಮಾಡ್ತೀನಿ, again I add one more electron. We try to add one more electron, we call it as X minus 2 gas. We call it as electron gain enthalpy. Easy is 2 ಅಂತಿನ, easy 2, ಅದಕ್ಕೆ easy 1. To add first electron, we call it as electron gain enthalpy 1, and to remove one more electron, we write it as this electron gain enthalpy 2 ಅಂತ ಕರೀತೀವಿ. And now this is positive quantity, second one is positive, first one is negative, remaining all will be positive only. I repeat, in the first case, when it is neutral atom, to add one electron, there is a repulsion between those electrons and incoming electrons. Energy is liberated, which is exothermic, therefore it is negative first order. Next, we try to add one more electron this time. Means to dominate over the repulsive forces, we have to overcome the repulsive forces, we have to put more amount of energy from the outside. You have to force that X minus 1 to get one more. ಅದು ಒಳಗೆ ಕರ್ಕೊಳ್ಳೋಕೆ ರೆಡಿ ಇಲ್ಲ, ದಬ್ಲಕತ್ತದ, ನಾವು ಹೊರಗಡೆ ನಿಂತ ಪುಷ್ ಅಪ್ ಮಾಡಬೇಕು. We should give more energy from the outside, then it becomes endothermic, and therefore always see X minus 3, that is electron gain enthalpy. Electron gain enthalpy of third is more than second is more than first, because the third process, second process are endothermic. ಆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಒಳಗೆ ಹೋಗ್ಬಿಡ್ಸಲಾಗ್ಯಾವ, ನಾವು ಹೊರಗಡೆ ಅಂದ್ರೆ ಅದಕ್ಕೆ ಏನು ಮಾಡಬೇಕು, ಎನರ್ಜಿ ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಇದು ಸಪ್ಲೈ ಮಾಡೋದಂದ್ರೆ ಏನು, ಒಂಥರ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿಕಮ್ ionization energy ಆದಂಗೆ ಆಗಿಬಿಡ್ತದೆ. You are suffering from the outside. From the outside you are giving. ಆ ಸಿಟಿ ಬಸ್ ಫುಲ್ ಆಗ್ಯದ, he is trying to board the bus. ಆ ಭಾಗದಿಂದ ಅನುಕೂಲ ಮಾಡಲಾಗ್ಯಾರ, ನಾವು ಆದಷ್ಟು ಭಾಗದಿಂದ ಒಳಗೆ ಹೋಗೋಣ ತಮ್ಮ ಅಂತ ತಿಳ್ಕೊಂಡು ಟ್ರೈಂಗ್ ಟು ಫೋರ್ಸ್ ಹಿಮ್ ಸೊ ದಟ್ he can pass into the crowd. ಹೊರಗಡೆ ಭಾಗದ ಒಳಗೆ ಅಂತ ತಿಳ್ಕೊಂಡು ಗೊತ್ತಿರ್ತೀವಿ ನೋಡಿ, ಅವನಿಗೆ ಹಿಂಗೆ ಹಿಡಿದು ಬೆನ್ನಿಗೆ ಗೊತ್ತಿರ್ತೀವಿ ನೋಡಿ ಜಸ್ಟ್ ಆ ಟೈಪ್. ಇಲ್ಲಿ once it has taken one electron, it is exothermic energy liberated. ಬಟ್ ಮುಂದೆ ಸೆಕೆಂಡ್ ಥರ್ಡ್ ಫೋರ್ತ್ ಹಿಂಗೆ ಕಾನ್ಸಿಕ್ವೆಂಟ್ ಆಗಿ ನಾವು ಮುಂದೆ ಹೋದಾಗ we have to supply energy from the outside, then it becomes endothermic. So electron gain enthalpy 3 is more than electron gain enthalpy 2, which is more than the first electron gain enthalpy. So ಅಲ್ಲಿ E3 is more than E2 ionization energy, ಆ ಟೈಪ್ ಇಲ್ಲಿ ಕೂಡ ಅಪ್ಲಿಕೇಬಲ್ ಆಗಿರ್ತದೆ. Once again, the definition of electron gain enthalpy is defined as the amount of energy liberated when electron is added to the gaseous neutral non-metal atom, which may be exothermic or endothermic in nature. Generally, whenever we add first electron, it is going to be exothermic, means heat is liberated, energy is liberated because of the repulsion between the outer shell electrons and incoming electron. But in the second case, when you try to add second or third electron, we have to put more pressure from the outside, means we have to supply energy from the outside, then it becomes endothermic. So naturally, first one is exothermic. Next subsequent ಏನಾಯ್ತು ಮುಂದಿನ ಎಲ್ಲ ಪ್ರೊಸೆಸ್ಗಳು ಎಂಡೋಥರ್ಮಿಕ್ ಆಗಿರ್ತಾವ, ಅವೆಲ್ಲ ಪ್ಲಸ್ ಕ್ವಾಂಟಿಟಿ ಅವ, ಫಸ್ಟ್ ಏನು ಮಾತ್ರ ಮೈನಸ್ ಅದ. ಹೀಗಾಗಿ ಥರ್ಡ್ ಈಸ್ ಮೋರ್ ದನ್ ಸೆಕೆಂಡ್, ಸೆಕೆಂಡ್ ಈಸ್ ಮೋರ್ ದನ್ ದಿ ಫಸ್ಟ್. ಇವೆಲ್ಲ ಯಾಕೆ ಹಿಂಗಾಗ್ತಾವಪ್ಪ ಅಂತಂದ್ರೆ ಡ್ಯೂ ಟು ದಿ ಇನ್ಕ್ರೀಸ್ ಇನ್ ದ ಸೈಜ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗಿರ್ತದೆ. ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ಒಳಗೆ ಹಾಕಬೇಕಾಗ ತೆಗೆದಲ್ಲ, ಒಳಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಫೋರ್ಸ್ ಮಾಡಬೇಕಾಗ ಅಷ್ಟು ಸರಳಾಗಿ ತಗೊಳ್ಳೋದಿಲ್ಲ. ಅದಕ್ಕೆ ನಾವು ಆದಷ್ಟು ಅದಕ್ಕೆ ಜೋರಾಗಿ ಫೋರ್ಸ್ ಹಾಕೋದ್ರಿಂದ ಹೆಚ್ಚಿಗೆ ಎನರ್ಜಿ ಕೊಡೋದ್ರಿಂದ ಒಳಗಡೆ ಹೋಗೋಂಥ ಸಂದರ್ಭ ಬರ್ತದೆ. ಜಸ್ಟ್ ಲೈಕ್ ಒಂದು ಆರ್ಟಿಫಿಷಿಯಲ್ ಸ್ಯಾಟಲೈಟ್ಗಳು ನಾವು ಆರ್ಬಿಟಿಂಗ್ ಮ್ಯಾಗ ಕಳಿಸ್ಬೇಕಾದ್ರೆ ಹೆಂಗೆ ಎನರ್ಜಿ ಕೊಟ್ಟು ಅದಕ್ಕೆ ಸಪ್ಲೈ ಮಾಡಿ ಇಟ್ ಗೋಸ್ ಟು ದಿ ಆರ್ಬಿಟ್, ಲೈಕ್ ಬೋರ್ಸ್ ಮಾಡಲ್ ಆಫ್ ಅಟಮಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ ಟೈಪ್, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ಗಳು ಟೈಪ್, ಪ್ಲಾನೆಟ್ಗಳು ಕೂಡ ರೆವಲ್ಯೂಷನ್ ಆಗ್ಬತ್ತು, ಸೂರ್ಯಗ್ರಹಣ ಮತ್ತು ಚಂದ್ರಗಳು ಅಂತ ತಿಳ್ಕೊಂಡು ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಿರ್ತೀವಿ ಲೈಫ್ ಮಾಡಿ. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ electron gain enthalpy. Now we shall focus how does this vary along the group and around the period. In fact, it represents the non-metallic character. Generally, non-metals have got tendency to take the electron, and metals are one which try to give the electron. Now we shall see the variation of electron gain enthalpy down the group and along the period. Generally, halogens, point to be noted, halogens, 17th group elements, they have the highly negative electron gain enthalpy. Point to be noted, halogens, 17th group element, fluorine, chlorine, bromine, iodine and aspartame. Here halogens have highly negative electron gain enthalpy. Highly electron gain enthalpy. I repeat, statement in the NEET or CET, true or false. Halogens have highly negative electron gain enthalpy, and noble gases or inert gases have highly positive electron gain enthalpy. ಯಾಕೆ ನೋಬಲ್ ಗ್ಯಾಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡಲ್ಲ, ತೋಳೋದಿಲ್ಲ. So they have very large amount of values. And even alkali metals also, alkali agni alkali earth metals are alkali metals also have high ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ ವ್ಯಾಲ್ಯೂಸ್. ಅರ್ಥ ಮಾಡ್ಕೊಡ್ರಿ, ನಾನ್ ಮೆಟಲ್ಸ್ ಇರ್ತಾವ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತಗೋತಿರ್ತಾವ, ಬಯಸ್ತಿರ್ತಾವ, ಅಂಥವಕ್ಕೆ ಏನು ವ್ಯಾಲ್ಯೂ ಬರ್ತಾವ, ನೆಗೆಟಿವ್ ಬರ್ತಾವ. ಇವು ನೋಬೆಲ್ ಗ್ಯಾಸ್ ಆಗಲಿ ಅಲ್ಕಲಿ ಮೆಟಲ್ಸ್ಗಳಾಗಲಿ ಅವಕ್ಕೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡೋಂಥ ಟೆಂಡೆನ್ಸಿ ಅದ. ಅದಕ್ಕೆ ಅಲ್ಕಲಿ ಮೆಟಲ್ ಎಸ್ಪೆಷಲಿ ಅಲ್ಕಲಿ ಮೆಟಲ್ಸ್ಗಳು ಅವಕ್ಕೆ ಟೆಂಡೆನ್ಸಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡೋಂಥ ಒಂದು ಪ್ರವೃತ್ತಿ ಅದು, ತಗೊಳ್ಳೋ ಟೆಂಡೆನ್ಸಿ ಇಲ್ಲ. ಅಂಥವತ್ತೆ ನೀವು ತಗೋ ಅಂತ ನಾವು ಫೋರ್ಸ್ ಮಾಡ್ಬೇಕಾಗ್ತದೆ, ಅದಕ್ಕೆ ವ್ಯಾಲ್ಯೂಗಳು ಏನಾಗ್ಬಿಡ್ತಾವೆ, ಪಾಸಿಟಿವ್ ಆಗ್ತವೆ. ನೋಬೆಲ್ ಗ್ಯಾಸ್ ಕೂಡ ಅಷ್ಟೇ, ಬಿಕಾಸ್ ಆಫ್ ಆಕ್ಟೆಡ್ ಸ್ಟೇಬಲ್ ಕಾನ್ಫಿಗರೇಷನ್ ನೈದರ್ ದೇ ವಾಂಟ್ ಟು ಗಿವ್ ಎಲೆಕ್ಟ್ರಾನ್ ನಾರ್ ದೇ ವಾಂಟ್ ಟು ಟೇಕ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡೋದನ್ನು ಲೈಕ್ ಮಾಡಲ್ಲ, ತಗೊಳ್ಳೋದು ಇಷ್ಟಪಡೋದಿಲ್ಲ. ಹಾಗಾದಾಗ ನಾವು ತಗೋಂತ ಫೋರ್ಸ್ ಮಾಡ್ಬೇಕಾಗ್ತದೆ, ದಟ್ ಬಿಕಮ್ಸ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್. ಸೊ ಒನ್ಸ್ ಅಗೇನ್ ಡೆಫಿನಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಎಂಥಾಲ್ಪಿ, ದಿಸ್ ಈಸ್ ದಿ amount of energy liberated whenever an electron is added to the outermost shell of an isolated gaseous neutral atom, and the first electron gain enthalpy is always negative exothermic, whereas the remaining second, third and fourth they are positive in nature. And more is the electron affinity, more is the electron gain enthalpy, more is the non-metallic character. ನೆನ್ಪಿಟ್ಕೊಡ್ರಿ, we study metals with ionization energy concept, where lowest is ionization energy, metallic character is most. And here for non-metallic property, generally the non-metals will have a higher means negative value for electron gain enthalpy. Noble gases and alkali metals will have the more amount of this electron gain enthalpy, and no need to buy at any NCERT values. Simply see looking NCERT books and copying the things of that also no use. Just to study the trend what happens. And finally down the group metallic character increases, therefore electron affinity or electron gain enthalpy should goes on. What happens? We have to give more amount of energy to put the electrons inside the valence shell. So along the period it goes on increases, along the period it goes on decreases, along the period down the group it goes on increases. So this further will be continued in the next visit. We take up values for some known elements in this connection. Then afterwards we can switch over to the electronegativity concept. Don't get confused. Once again, here we have discussed today's class the definition of ionization energy. ಏನಂತ ತಿಳ್ಕೊಂಡೆವು, this amount of energy required to remove the most loosely bound electron from an isolated gaseous neutral atom, and its variation down the group it goes on decreases because atomic size goes on increases. On the other hand, along the period it goes on increases because effective nuclear charge increases, non-metallic character increases. This is the information. Soon afterwards, and we have given the graphical representation for this variation down the group in the alkali metal family: lithium, sodium, potassium, rubidium and cesium we have given. And very interesting point, along the period we point to be noted, we have learnt especially beryllium and boron, nitrogen and oxygen, why the changes are noticed due to penetration effect, the 2s electrons compared to 2p, compared to 2p3, 2p4, all those reasons we have given for the beryllium and boron, nitrogen and oxygen. Finally we have come to know that halfly filled and fully filled configuration being more stable, to disturb it we have to supply more amount of energy. ಹೀಗಾಗಿ ಅರ್ಧ ತುಂಬಿದಾಗಲಿ ಸಂಪೂರ್ಣವಾಗಿ ತುಂಬಿದಂಥ ಆರ್ಬಿಟಲ್ಲು ಡಿಸ್ಟರ್ಬ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಎನರ್ಜಿ ಹೆಚ್ಚಿಗೆ ಕೊಡಬೇಕು, ಅದು ಒಂದು ರೀಸನ್ ಅದ. ದೆನ್ ವಿ ಹ್ಯಾವ್ ಡಿಸ್ಕಸ್ಡ್ electron gain enthalpy, that is amount of energy liberated when electron is added to an isolated gaseous neutral atom. Especially this electron gain enthalpy will give significance about the non-metallic character, so that we have taken. And always the first electron gain enthalpy is exothermic, negative irtuda, whereas second and third are found to be endothermic, they are positive in nature. So that is information. Next visit we shall take up some more points on this discussion. We take another term electronegative also. Till then, take care, stay home, see you after some time. Thank you.